Thank you very much. I'm very happy to be here and to talk to you. We have very little time. Usually I talk for a prolonged time, so you just have to hear 1 hour, but I'm going to cover a lot of material. So I have put all the papers and the data I'm going to talk about on the web page. So if you want to read, I'm going to mention quite a lot of articles and research studies, and I'm going to give you the icing on the top. If you want to read the details, I've put them on the web page. And also, if you want copies of the slides, you're more than welcome to drop me an email, and I'm happy to share the slides with you. If you forget all of this, you can always Google my name. It's very strange, not only in the UK, worldwide, so you'll find me very easily. So we're going to have a lot of materials to deliver, and I'm going to maybe not have questions at the end, but definitely I'm going to challenge you. So I'm going to try to annoy you and challenge you to think out of the box. And some of you may like it and some of you may not like it, but you can see it as an intellectual exercise. But the reality is that you're going to be under the spotlight. It's happening in other countries and in the UK on forensic science, and they've kind of left a bit forensic psychology aside. But now forensic psychology is getting more and more attention, and this is issues that are going to come up on your evaluations and your assessment. So you don't have to agree with me, but I think it's important for you to listen, to think about it, and if you don't agree, that's fine. Know what's going to come up so you can prepare some kind of defense. So I'm going to start that people are biased. I think that it's a fact of life, and I don't think I need to tell you because you're a psychologist, right? Pick up your hand if you have an undergraduate degree in psychology. Pick up your hand if you have a postgraduate degree in psychology. Almost everyone, so I don't need to talk to you about Psychology 101 to mention that people are biased. When I talk to the DNA examiner, to fingerprint examiner, to toxicologists, to blood pattern analysis, people who have educations in chemistry and physics, they have no idea. I say, what, people are biased? You mean people are not objective and rational, and they go to court and they say we're objective, we are, that's what they say in court, or said, we are infallible, and believed it. But you're a psychologist, you know that, and we can give a few just examples that we have people who are more attractive or less attractive. It's a fact of life. And the bias, more than bias against race and weight and gender, attractiveness is one of the strongest biases if you're interviewing for a job, or even in the criminal justice system, attractiveness is very important. There are endless papers showing that when you give people to make verdicts and you attach to the same evidence pictures of people who are more attractive or less attractive, if you're more attractive, you're more likely to be found innocent with the same evidence. If the evidence is overwhelming, you will be found guilty, but you will be sentenced to less years in jail. Attractive, but guilty, attractive bias. So attractiveness, even in the criminal justice system. There is a small exception that if you're attractive, rather than being found innocent or less years in jail, the opposite. If you're more attractive, you'll go to jail even more, and that if the crime is connected to being attractive. So if you're a murderer, rapist, bank robber, be attractive, you'll be found innocent more likely. But if you are accused of fraud, for example, going to women and promising them to get married and taking their money away, or vice versa. So you're using your attractiveness for committing the crime, then the more attractive you are, then the more bias against you. Either way, attractiveness is a bias. I'll give you one other example. If you look at these two pictures of two faces, then you have to make a judgment of how similar they look to one another. So just look at it for a second and think how similar, and rank them on a 0 to 10 scale. 0, they're totally different. 10, they're identical. So just have a look for a few seconds. How many people think 0? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have your assessment of the similarity, and I really don't care about assessments, I care about bias. So what we do this. However, we tell half the participants that the two people there are genetically related. The other half we tell they're not genetically. So this is a mother and a daughter, which they are, but it's irrelevant information, or the stranger. We show two pictures of men and we say they're brothers, or they're people are not connected. That doesn't change the faces, and it doesn't matter to me if you looked at the eyes or the jaws or the nose or whatever you did, it doesn't change. But if you look at the literature, again, if you go to my webpage, if you don't know Latin, like father, like son, perceived resemblance and the belief in genetic relatedness. So if people believe that people are genetically related, they are biased and they see the faces and rank them as more similar. So, you know, bias exists. We know that, you're psychologists. And the reason for that is the way the brain processes information, the way we perceive and interpret and evaluate and make judgment and comparison. So far, so good. Now, let's talk about experts. I'm dying to ask this question, probably I shouldn't. And you're British, so I don't know if you'll even be honest with me. How many of you consider yourself experts? How many of you have done professional evaluations and wrote a report on people? How many of you appeared in court? And when you write the evaluations, you write, I'm not an expert, I'm an ignorant idiot. No. And how many of you who wrote reports get paid for it? Well, if you get paid for it, you're experts, and you're saying they're experts, unless you write, I'm not an expert, I'll do evaluation, but please pay me. So you're British, you're modest, or you're afraid to hang yourself, which I will do in a minute, and you're giving me the rope now. So you believe you're experts, or you don't believe and you misrepresent yourself as expert and write reports, do evaluations, and charge money for it. Whatever way you want to call it, experts. And as experts write it, as non-experts who write report and get paid for it, you assume, believe, and write in your report that you're independent, that you've done impartial analysis, that you use sometimes objective approaches and technology, that you're here to help find the truth, right? To communicate accurately and fairly. Right? When you do assessments of competence, sanity, risk assessment, you're trying to communicate your findings effectively and fairly and objectively and impartially, not be biased. All of you do that, right? And I believe in the UK, I've written a few reports, we're even required in the report to say we are unbiased and objective and all that stuff. And in the UK, we have the Procedural Rules section 33.2.1a, and in the US, the Federal Rule 702, which now has been adopted by most of the states, that says that experts, I know you're not experts, but experts who write reports and testify in court have to be objective and impartial and all those beautiful things that we're talking about. And no wonder the courts love you and seek and rely on experts who come in because they know, because of great research in psychology, that eyewitnesses are not very reliable, and they know that confessions are not reliable, so they have the experts, the impartial experts coming in and helping them, and that's wonderful, of course. And that's, as I said, what you write in the report. I think you have to write it in your report in the UK. It's a requirement to do that. So that's all nice and good, except one problem, that you and experts have a brain too. So I'm talking about the brain mechanism that cause novices and naive people to be biased. Experts, you have a brain too, and your brain is different than novices in many ways, and we research the brain, but you have a brain nevertheless. You deny being expert, maybe you should deny having a brain. I'm not even going to ask that question. If we were in the United States, you just plead the Fifth Amendment and don't say anything, maybe you're better off. So people are biased, and experts too. Now let's get to forensic experts. And let's start with experts that, at least we believe, and I do believe it's true. I'm not sure what you think. I'm not going to ask you any more questions because I don't believe what you say. DNA and fingerprint experts, not people who look in forensic science and hair analysis and bite mark, or forensic psychology, which you do, right? As risk, sanity, competency. Let's talk about DNA experts, fingerprint experts, firearm experts, handwriting experts. And they do science, and they come to the court. It's changing, but when I started 10 years ago, they come to the court, and there's hearings in the United States are called Dolbert hearings. Here the gatekeeper and the fingerprint examiner comes in and says, I'm objective and I'm impartial and I'm infallible and our error rate is 0. And the court accepts that, the court adopts that, and they appear in court, and everything is great until I came and caused some problems by collecting data. Because there was no data to support their claim. Not only they claimed things that are outrageous, that they have 0 error rate, they had no data. But the court accepted it. So for example, in a paper in Science and Justice, 2011, we talk about subjectivity and bias in forensic DNA mixture interpretation. And we take a bunch of forensic DNA examiners. And before you ask me, they're competent, they appear in court. Every time I find a problem, it's a bad apple. My random sample, the one bad apple. And we give them DNA evidence of a mixture, and they're the suspect. And they have to decide, can the suspect be a contributor to the mixture? So it's a gang rape case. It's a real case, by the way. And the number of suspects, and they look at each one, their profile, and the biological material at the crime scene, and they either say, this person cannot be a contributor, this person can be a contributor, or they can say inconclusive, they cannot decide. And we give it to a bunch of examiners with no background information, and almost all of them say impossible. However, in the criminal case, the DNA examiners, it's not one, a couple of examiners, they get background information. They get information that this suspect, one of the suspects plea bargained. He testified against other people, and we have evidence that this suspect was part of a gang rape. And they get further pressure, and I'm not asking you, but I assume that like every forensic evaluator in the sense, you briefed about the case, you told a lot of things about the case, and they're told the background about the case, right? The first thing they talk to you, they want to tell you the background of what they want. They want to poison your mind, to contaminate you, telling them that in this state, it's in the US case, the evidence of the suspect who confessed against his friend, they cannot bring it to court unless with corroborating evidence. And if they say that he can be a contributor, then the evidence will be admitted. And they say, yes, both of the examiner will look at it with this background, irrelevant information for the DNA examiner, very relevant to the detective and the prosecution and the jury and the court, but the DNA examiner needs to look at the profile and make a decision based on the evidence, the relevant evidence for a DNA examiner, which is that. So we look at that and we find that there are biases, but not only between experts, but I wanted to take it to the extreme. I like to be extreme. I said, okay, different examiners reach different conclusions, but there are individual differences. Some people are risk takers, some people don't like risk, different training, different eyesight. What happens if we give the same forensic examiner the same evidence twice, but each time give them different briefing about the case, but the evidence that they need to use is going to be the same? Surely, it's going to be the same. Well, not. So what we did in fingerprints, we give the same examiner. One time, the suspect confessed to the crime. One time, the suspect didn't confess. One time, an eyewitness identified the suspect or someone else. The detective knows or not, and the nature of the crime. And we have a whole bunch of studies like that. And it's not two different fingerprints. It's not between. It's within the same person, and they reach different conclusions. And it made a lot of noise because in the first paper, I took real criminal cases. a fingerprint expert went to court and said this is an identification, and they're not very confident, and they say, I don't think 99.9. I'm 100% sure, I cannot be wrong, this person is the person committed the crime. We gave the same fingerprints, the same examiner, the same fingerprints, with a different story, and they need to believe the context. So we fabricated. They thought it's a real criminal case. They didn't know we're doing an experiment. You can ask me later, probably not when I have video, how do you get ethical approval without informed consent for people to collect data? I will talk about that not when it's been recorded, but we have ethical approval. And depending on a lot of factors, we get between 17 to 80% say it's not a match. On the same evidence in fingerprints that they said they're 100% sure that it was an identification. And we have a lot of different manipulations. If people are interested, I can tell you the factors that determine the changes, or you can just go to my webpage and look at meta-analytically quantifying reliability. A forensic examiner, contextual information renders experts vulnerable for making erroneous identification, why experts make mistakes, and so on and so forth. So it's not only between experts, but it's also the same expert seeing the same evidence twice. And I just want to tell you where I'm going so you don't think I'm tricking you. I'm going to go to forensic evaluations example. What happens if you have a file and you're evaluating it, and one time you have a picture of the suspect and they're white, and one time you have a picture of the suspect and they're black? Are you going to reach the same conclusions? Even if two different examiners reach different conclusions based on race, not exactly what we want to do, right? As experts who are impartial. But here we're talking the same expert looking at the same evidence. Now, this is the conclusion, but what about the observations? This is something very important. I make a distinction. I have a hierarchy of expert performance between conclusions and observations. All they did in forensic science and in forensic psychology, which I'll get to in a minute, they compare the conclusions of the examiners, and if they reach different decisions, they believe that different mechanisms, how they draw inferences. I say, hey, wait a minute. Even though they reach different conclusions, different assessments, they may use the same inferences, but they observe the data differently. Let me give you an example, because it's a complex concept. Between observations. So, for example, two drivers are driving on the road, or we put them in a simulation, they're going 45 miles per hour, they're getting near an intersection, 15 meters, and suddenly the light turns red. And I have a video, and you could, if I believed you, I'd ask you, what do you do? And you can vote whether you stop or you don't go. And driver A goes for it, and driver B, presses the brakes. So what do we think about it? What does that mean? What is the conclusion? You have driver A goes for it, driver B stops. So driver A, the higher risk taker, and the driver B who stops when they go 45 miles per hour, 15 meters. This is looking at their conclusion, at their decision. And that may be correct, but may be wrong, because you need to look at the observations. For example, if you look at the decision threshold, it could be that driver A is a low risk, exactly the opposite, because driver A has a threshold of 8%. If the risk of having an accident is 8% or more, I'm going to press the brakes. 7, 6%, I'm going to go for it. Driver B is a higher risk taker. He will press the gas, the pedal to the metal, or whatever we like to say in England. 8, 9, 10, 11%. He's going to press the gas. He's not going to, he's a high risk taker. However, the observation, their initial observation, what do they think? What are the chances, in this scenario? It could be that they go for it because they say it's 5%. And even though they have a lower threshold, they go for it. And this driver believes it's 15% when they look what is the data there, and that is above the threshold. So we need to look not only at the conclusion, but what is the data, what they observed. Some data is very clearly observed. Sometimes you require some interpretation when you interview people, when you get certain information. Sometimes you make assessment that they are using aggressive behavior, aggressive language, and all your items on all the tests that you do. Some of them are purely data. Some of them require, and you may differ in that and not in how you aggregate and use that. So I've talked to, until now, about bias between examiners and bias within examiners, and showed differences in DNA and fingerprints very briefly. Now let's talk about observations. I want to move to a more basic level or a different level. Maybe the problem is in observations. So let's go to fingerprints, because in fingerprints we have real nice observable data. They count minutiae, these fingerprints, and they have clear definition of how the friction ridge splits and isolates, and they count the minutiae. And then they compare, and if you're interested about fingerprints, I can talk about it in detail, but basically they have a fingerprint from a crime scene. It's called a latent fingerprint. It's small, it's missing, it's smudged, and they look at it, and then they have a suspect, and they look at my fingerprints, and they have to decide, are the two fingerprints similar enough to conclude that they come from the same source? Even if they take my fingerprint twice on the table, they're not going to be identical because the elasticity of the skin and the pressure. If that was a job, it's easy. Are they similar enough? Because the same, it's like handwriting, which you have experience. When you sign, you don't sign exactly the same every time, these variations. So two fingerprints that look quite different can come from the same person, and two different people can have very similar fingerprints also. That's why it's very tricky. So they have to decide that it's similar enough. That is the inference they have to draw. What is similar enough? No criteria. Ask any fingerprint examiner, look at any book, go to any training. It's in the eye of the beholder, and they cannot articulate it. So it's a subjective judgment how they draw inference about the relative similarity. That's a conclusion. I'm going to the observation. Just look at the print, one print. Don't compare it even to a suspect. What do you see in the print? The data to compare, and it's well-defined, very well-defined items. They're called minutiae. So I said, surely, different examiners see the same data. So I sent one of my postgraduate students to look at the research that's been done on this, and they said, nobody's done that. I said, I hope my postgraduates are not totally incompetent. What do you mean? Fingerprint has been in court for 100 years. We sent people to jail once it's fingerprint evidence. Nobody asked this question whether different fingerprint count the same minutiae if they observe the same stuff. That's a trivial question. I'd like to say it's very clever because I thought about it. But it's not. It's an undergraduate third-year project, right? Give a bunch of fingerprint examiners the same print and tell them count the minutiae. Don't draw inferences. So we did that. And you can see that we have here 10 fingerprints and 10 examiners, and the numbers are all over the place. Look at the minimum and the maximum and the ranges. And that's on the observation of the data. So one fingerprint can say it's a match, and another one it's not because they use different criteria to relative similar, but because they observe different things. Sometimes you have high numbers. You have 18 to 24. It's quite high. Either way, they probably will make an ID. But they'll never make it 4, and they will make one at 12. So you're going to go to jail depending the examiner what they observe. Different examiners count different number of minutiae. Shock. I say to fingerprint examiners, say impossible. So when I train them, and I train the Metropolitan Police and GMP and FBI and LAPD and everywhere, I bring fingerprints with me, and I bring magnifying glass. So I say, bring your own, and I give them the same print, and we go around the room, and they give different. I said, you look in the same print. They say, impossible. I said, look, and they are, and I say, refute it. Show me, and they can't do that. But then I push it further. What happens if we're going to give the same fingerprint examiner the same print and ask him twice to count the minutiae? Surely, I can go to one dentist, and I'm doing it with dentists now, and people who appraise diamonds, we pay a lot of money, right? They say what it weighs, it's objective, but the clarity and the color. So you give two different examiners, they may say different clarity. But the same one, I go to one dentist, he says, I need a cavity. The other one says, oh, you're doing great. But the same dentist looks at the same x-ray. One time they say you need a root canal, one time you say you're doing fine. It's a bigger problem than the same examiner. So let's give the same examiner the same print. And there's a lot of myths about expert performance in forensic science and in forensic psychology, that you know what you're doing. And the fingerprint examiner says it will not work, because once a fingerprint examiner sees the fingerprint, they remember it forever. So I do it 6 months apart and give it to them at T1 at T2. And you can see that sometimes they do give the same number of minutiae. This is new exam, time 1. Sometimes there's a difference of 1, 2, 3. They get quite big. To make it more palatable, let me subtract T1 from T2. So if it's the same number, it's 0. If it's a difference of 1, and so on and so forth. And you can see that there are zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the same examiner, just not making a judgment, just looking at, deciding about the minutiae. And then I decided I'm not going to believe the fingerprint examiners. You're in a good company. I won't do it 6 months apart. 6 weeks, one day apart, and they don't count the same minutiae, the same examiner. So this believe once we see. So this is, to say the least, I think disturbing, because I'm showing that experts are biased, even in DNA and in fingerprints, not only between experts, but within experts, and not only in conclusion, but also in their observations. You think it can't get any worse? Okay, so what about without bias? Even I didn't think that there's a problem of reliability, that if we don't give bias, it'll reach different conclusions. But you know what? Even without bias, they produce different results. And what's nice is I started this 10 years ago. Now different people are doing it. So there's a study sponsored, and this is people from the FBI and a research institute in fingerprint repeatability and reproducibility, they call it, because reliability is the legal kind of connotation. So they take fingerprint examiners, give them a pair of prints, and they decide if it's an ID or not. And then they give the same examiner the same print. Are they going to decide that it's without contamination? Don't tell them one time the person confessed to the crime and another time no. Just give them the prints and they make a judgment. Now, I'm not a fingerprint examiner, so I flip a coin. I would get 33% the same, because they say ID, 100% sure, exclusion, it cannot be from the same person, or I cannot decide inconclusive. So at time 1, I throw a coin, time 2, I throw a coin, 33% of the time I'll reach the same conclusion. The same with you, you have to decide if someone, is competent to stand trial or not. So if you give me the file, I'm an expert, I charge lots of money, I'm not even going to look at the file, I flip a coin. Heads, they're competent, tails are incompetent, and if you do the study and give me a month later the same file, I'll flip a coin again, I'll be right 50% of the time, right? Because there's 2 choices. Here there are 3, and in this study, 10% of the time, they reach a different conclusion. They go to court and say we're objective, we're reliable, and objective and impartial, and all that, and we have 20 years experience. 10% of the time, not 2 different examiners, the same examiner looking at fingerprints will say one conclusion, and another time another conclusion. So this is, in my view, quite extreme. And I've kind of started and developed a hierarchy of expert performance. It has 8 different aspects. I didn't cover all of them because we don't have too much time, and you can read about it if you want in the Journal of Applied Research in Memory and Cognition. And the idea is not to make them look bad. I work to improve, not to discredit them, and they have expertise. It's not, like some other areas, but you cannot improve performance if you don't know what the performance, if you can quantify and look what people are doing or not. And you're all nodding. We're going to talk about forensic psychology in a minute and see what you know about your own performance and what the data and research shows. But you need to see where there is no data. We don't know how well we're doing. You may be doing great, Maybe not, but let's find what you're doing great and what you're not doing great, and then we can think of how we can make it better. And then we try something and we collect more data and develop procedures. We kind of need some framework. For example, in the forensic science, we have developed a procedure called LSU, linear sequential unmasking. It's been adopted in the UK by the forensic science regulator. In the United States, they had a National Commission on Forensic Science. They adopted linear sequential unmasking. And now in court, people are asked, the expert, did you use linear sequential unmasking? You can read the detail. It's all published, and it's for forensic scientists who are not very educated necessarily. So it's a 2-page paper. We don't write more than 2-page papers, so maybe they'll read it if we're lucky. So it's a 2-page paper, and basically it's a context management toolbox. What does the examiner need to know and when? They should not be exposed to information that is irrelevant. What is relevant or not is a big question, which I will not get into now, but some things are irrelevant. When I testified in front of the US National Commission on Forensic Science, it's on my webpage, you'll see I give this presentation, and the head of detectives of NYPD gives me a hard time about what's relevant or not. And there are things that are complicated, but there are things that are never relevant in forensic science regardless of what it is. For example, whether the suspect confessed to the crime or not, that the detective believes they're guilty or not, either eyewitnesses against the suspect. That's irrelevant when you're looking at the DNA or the fingerprint or the bite mark or the handwriting. And in your domain, we can talk, but I believe that when you're assessing somebody's sanity or risk or competence, race is irrelevant. Now, you may have to see, because you're interviewing the person, but if you see a file and you read the vignettes or whatever, race should not affect it unless you want to claim that, white people are more likely to commit crime and they get points for being white or whatever. And it may be true that men are more likely to recommit or women are more sane or less sane. Collect data and put it as part of the inventory. That's okay because there's transparency. I tell the fingerprint examiner, I don't mind if you flip a coin, guilty or not. It doesn't matter to me. But you cannot go to court and say it's based on the fingerprint, because you're deceiving the court and the report. You can say, I knew the person confessed to the crime. And then the jury or the judge can say, hey, they say they used the fingerprint, but they knew the suspect. They say it was information they knew, but they blocked it out by mere willpower, which we psychologists know does not work. So there's a linear sequential unmasking saying don't be exposed to irrelevant information. And relevant information, we optimize what you know. Don't have everything at the forefront, because then you always go into backward reasoning. You do circular reasoning. Like I like to say, the Romans do archery, bow and arrow, they shoot it, the arrow hits the tree, and then they draw the target. Always bullseye. And that's how we do it. That's a lot of human reasoning. So if you know ahead of time a lot of information and then you do the evaluation, it may interfere. But sometimes you need the information, but don't have it in the beginning, have it when you need it. So basically, it's one example of a context management toolbox, what information you have and when you have it, and that's for you to decide by trying to think about it. So now, what about forensic psychology evaluation? So you're going to be under the spotlight, and it seems to me that a lot, I'm careful not to say all what you're doing, but a lot of what you're doing have at least, if not more, subjective evaluation and interpretation than the fingerprint examiner and the DNA examiners. And what have you done looking at this area of bias and reliability? You've done a bit, but I have to say, I wrote it a bit extreme in a paper and the reviewers wanted me to tone it down. What is your excuse? Because when I talk to DNA examiners and toxicologists, we've never studied psychology. We don't know. We just studied chemistry. You're a psychologist. You're an expert in interpreting human behavior and evaluating people. Don't you know that you're biased? Don't you know that you have problems in making your evaluation? And you know what? Why did you do it? This is your topic of expertise is human behavior, and you're well educated, so I'm not sure what your excuse. In the paper, it's said a bit nicely for the reviewers to shut them up. But anyhow, there's a paper that came out a week ago, I believe, online. It's not even available in paper, with Professor Patricia Zaft, and we're looking at it published in the International Journal of Forensic Mental Health, Understanding and Mitigating Bias in Forensic Evaluation, Lessons from Forensic Science. And there is a paper that 2 days ago we submitted the revisions, and I hope it will be accepted, to be published in Psychology, Public Policy and Law. Dan Murray and I, on the hierarchy of expert performance, I showed you some of it, applied to forensic psychological assessment, where we're going and applying it to look at forensic psychology. What do you guys do? So we found papers. It's not like forensic science. Well, what? The fingerprint doesn't lie. What are you talking about? So there is work in forensic psychology, and we found, and Dan Murray and Patricia Zaft know it by heart. It's their day job. There is find variability, low to moderate agreement between evaluators. There is field studies and experimental. So there is some stuff that's going on, but I'm not clear when I look at it. Is it because of bias, or because lack of reliability to begin with? So it's not clear the distinction that I make in forensic science, where they make different conclusions because of irrelevant information, or they wouldn't make the same decision even if they were not exposed to the briefing that was given and a lot of information that you don't want to know and didn't need to know, which may be really interesting and juicy and fun to hear, but not part of what you need to know as an expert. And the forensic scientists, I call some of them, they have the Sherlock Holmes syndrome, you know, like CSI or Quincy TV shows where the forensic scientist is a detective. You want to be a detective? Go ahead, join the police, but you're a scientist looking at the science. You know, the detective is not, you're not part of the police. And in the paper with Patricia Zaft, we have a whole, I developed in forensic science, where we look at biases. Where do biases come from? And part of it is human nature, part of it is environment, culture, and experience, and some of it is case-specific, and we go to different levels of what in the case information can bias you, the reference materials that you get, irrelevant, base rate, organizational factors, training and motivation, and some basic ways the brain works. And I've developed this in details in forensic science. In the paper that I have with Patricia Zaft, we apply it, and again, it's on my webpage in the Journal of International Journal of Forensic Mental Health, applying the bias. The other thing is that I wonder about is how much the differences are in the conclusions versus the different forensic psychological evaluators. You have the same inferences, but there's huge variability, not because of the inferences, but in the observations. They observe different things when they look at the video, whether the person was aggressive or using humor to distract, or all those things, the items that you do, those basic things. And then again, we're talking about applying this area to forensic psychology, and that's a paper with Dan Murray. And again, we send the revisions this week, and hopefully it will be online very soon in psychology, public policy, and stuff like that. So what are the kind of things that happen when we apply it in the paper that I'm telling you about? First of all, we find basically nothing about the observations in forensic evaluation. All the literature, not much, but whatever is there, focuses totally on the conclusions. They don't go back and separate and tease apart the observations they make. What about bias between forensic evaluators? Yes, there is information. Not very encouraging, if you ask me. Time is moving along. There are field studies showing that they are vulnerable for what's called, for example, and I'll show you examples of that, of the adversarial allegiance who hired you will make a difference. I'll show you that to you in a minute. And there is field studies and experimental studies on it, and that's a paper by Dan Murray and Marcus Cassini and other people. And what they did, they basically hired 108 forensic evaluators and asked them to do what you guys do, which is forensic psychology evaluation, but half of them, they said, I'm from the prosecutor, can you look at it? And half of them said, I'm from the defense. And gave them the same information, so they didn't manipulate if the suspect was black or white or fat or a woman or had a criminal record or whatever. Exactly the same thing. And they did things that you guys do, PCLR. How many of you have used PCLR? Pick your hand up. You know what I'm talking about better than me. How many of you used static 99R? And these two stuff, which I don't know a lot about, but I looked at the journals, they have been published and proven in the literature to be objective and reliable. There's literature saying they're great. But when they did it and manipulated the side that hired them, they had 4 cases, and you can read the details in the paper, they find differences if the person believed that they're working for the prosecution or for the defense. In 3 out of the 4 cases, huge differences. Does that remind you of the faces? If people believe they're genetically related or not, they're not lying. It just changes the cognitive processes of what you observe, your interpretation, and your judgment, and your evaluation, and you do a lot of that. So have you done things on this? Yes, you have done them, but limited. Limited is better than nothing. But there aren't a lot of studies. There's a study by Dan Mary and a few other people, but I was not able to find dozens of studies and meta-analysis. You know, you can, in the paper we summarize them and review them in great detail. What about within? Has anybody looked if the same evaluator, not 2 different evaluators believing for the prosecution and the defense, the same evaluator looking at the same case at 2 different times, will they reach the same conclusion? Well, we haven't found, and we looked quite hard, any paper looking at that. There was nothing that we found on that. And you do such important work. The court, going back to my earlier studies, are so important, they rely on you. You write reports, and the outcome, somebody's life, you know, depends on it if they go to jail or not. In the US, if they're going to be executed or not in terms of competence to stand trial. You know, it's serious stuff. What about reliability between examiners? Not bias, but will you give different examiners the same case, which will reach the same conclusions? So this has been done for clinical administration, reliability estimates and stuff. This is an experiment, but it's a great thing that you know in Hawaii. So in Hawaii, in the United States, and it's by the way, it's a great place to collect data, so you can go and collect data there. They have a natural study. What's a study? Which requires a felony to be evaluated independently by a number of examiners. So I think it's 3 examiners have to independently evaluate it, and they're relatively independent. They're appointed by the court. It's not for the prosecution, the defense. And these 3 examiners look and do an evaluation. And that tells us the consistency from real cases in Hawaii. So if you look at competency, different conclusion in 29% of the cases. The examiners don't agree with one another. Sanity, 45%. This is insane. And scientists and experts who signed that this is the reliability. So this data, and again, it doesn't mean go home and quit your job. It means let's start asking, why do we have lack of reliability between examiners? Well, here at least you have data. We have data. So either data, yes, there is data. Worrying data, but it's data, and that's why it's important, because we are scientists, we're trained psychologists, right? We're not police officers who look at fingerprints and police officers who do firearm exams. We're academics, we're scientists, we're trained, we study for many years, and the data says, hey, there's that. But without the data, we can't start talking if there are problems and what the problems are. And these problems, if you're not motivated because you want to be a good scientist, you're under the spotlight. I'm going to make sure of it. You're going to be asked in court when you evaluate. You say that, but do you know that 45% When you come and tell me this person is or is not, 45%, if I give it to other examiners, I reach a different conclusion. So what about reliability? We see an examiner. Will the same examiner reach the same conclusion? We don't know. So the bottom, nobody looked at in forensic evaluations. And the 4 top ones, 2 out of 4, so that 2 out of the 8 layers, limited and worrying data. So again, this is to improve. It's not, you all look really sad. I'm sure you're going to dinner tonight and you'll drink alcohol and forget about it, and that's fine. But I'm not here to make you, and I'm happy that the forensic exams can get very aggressive, defensive responses, and I'd love to share with you, if we had time, emails and what they write to the journals. Initially, when it came out in the paper, they're so arrogant, they published not what they call me on the blogs and in the chat boards. They call me really nasty names. I have a folder of hate mail, I'm serious, all personal mail, but what they publish in the journal, when I publish it, the letter to the editor, and not one examiner. The chair of the International Fingerprint Society said, I read Dr. Dror's paper, and his examiners showing they're not objective. Well, all examiners are objective, and they're infallible, and if there are fingerprint examiners that Dr. Dror found that cannot do the job, and I quote, should go and seek employment in Disneyland and not do forensic work. That was the response initially. You don't seem very aggressive yet. I'm watching my back. So you're taking this on board. So it's not to make you feel bad. It's to start thinking, to quantify, to qualify. What do you do? What do you do well? Some things you do well, you can do them better. And some things, I'm putting my British hat now, and some things you do a bit less well, and you can do them better. It's always, scientists always want to improve, but you can't improve if you don't collect data on your performance, if you don't quantify and think about it. And again, this, we have a linear sequential unmasking that we've developed. Now it's adopted in the medical domain with some modification. You can develop your own procedures. You're intelligent people, you don't need me. But this is, again, in the sources of bias. And we have a paper, Patricia Zaft and I published already, where we take this and apply it to forensic psychology. We go each layer here from the 7 layers, what is relevant, what happened in forensic psychology, and collecting data, and ask you to collect data. This is about bias. Here it's not only about bias, we also have reliability, and not only bias that we're looking at. It's all about improvement. You are psychologists. This is your topic of expertise. I don't need to teach you psychology 101. You've taken, psychology undergraduate, postgraduate degree. You know that human minds are rationalized and all these terms. That's a basic of psychology. And as you apply it to your objects, your suspects or criminals or children or whatever, apply to yourself. Don't have what Emily Pronin called the bias blind spots. We have another paper, we just submitted it, where we did a survey of over 1,000 forensic psychology evaluators. And some of them says, we know about bias, but their bias, not me. So that is a bias blind spot, and we hope to publish it. Anyhow, the message is, I'm going to finish. I want the message to be positive, that as people, and I will call you, if you don't want to call yourself, as experts who write reports and contribute to finding the truth. You want to be as objective as you are, as impartial, and to accurately reflect and help the court reach very important decisions. It's an important domain. You're experts. I hope you're well paid, and if not, you should get well paid. But as scientists, you need to ask yourself all the time, am I doing well? Am I not doing well? Where can I improve? And you cannot do it by introspection. I know you're clinical, but I hope Freudian methodology is not what you use at your job. Collect hard data. When do you make decisions? What factors impact decisions? So you can improve and have more reliable, less biased interpretation and reach as much as possible conclusions. You are psychologists. You know how to do that. Thank you. Good.